In this video, I'm going to go over applications of quadratic equations. Let's look at the first example. Find two consecutive odd integers such that 5 times their sum is 23 less than their product. Now, odd integers are plus or minus 1, plus or minus 3, plus or minus 5, and so on. So any two consecutive odd integers must differ by 2. 1, 3, 5, 7, and so on. So let's start out by representing x and x plus 2 be our consecutive odd integers. Now let's analyze what the problem is saying. 5 times the sum of these integers, so 5 times the sum, which is x plus 2, is equal to 23 less than the product. The product is x times x plus 2. 23 less than the product means the product minus 23. So this is the condition that is detailed in the problem. Now the rest is algebra, so let's do 5 times 2x plus 2 equals x times x is x squared. X times 2 is 2x minus 23. 10x plus 10 is x squared plus 2x minus 23. If we subtract 10x from both sides and subtract 10 from both sides, we wind up with 0 on the right equals x squared minus 8x minus 33, which is obviously a quadratic equation. Next, we need to solve this quadratic equation. So we have x squared minus 8x minus 33 equals 0. To solve this quadratic equation, we need two integers, p and q, so that when we multiply p and q, the answer is 1 times negative 33, that's negative 33. And when we add up p and q, that should give us the coefficient of x, which is minus 8. So let's go through the list of factors of negative 33. We have 1 and negative 33 doesn't add up to negative 8. Negative 1 and 33 doesn't work. The negative 1 plus 33 do not add to negative 8. Next we have 3 times negative 11 multiplies to negative 33, and it adds up to negative 8. So this is the pair of p and q we're looking for. So we factor the left-hand side as x plus 3, x minus 11 equals 0. By the zero factor property, we get x equals minus 3, or x equals 11. Notice this is the first odd integer, so the next, or the consecutive odd integer to that, x plus 2 would be negative 1. And in the second case, when x is 11, the next odd integer would be x plus 2, and that's 13. So this problem has two solutions. the first solution is minus 3 and minus 1. These are two consecutive odd integers that satisfy the conditions of the problem. And the second solution is 11 and 13. These are consecutive odd integers that again satisfy the conditions of the problem. Second example. Find three consecutive even integers such that the square of the sum of the first and second integers is equal to twice the third integer. So even integers are, the positive even integers are 2, 4, 6, 8, and so on. And the negative even integers are negative 2, negative 4, negative 6, and so on. And 0 is an even integers. Even integers are the integers that are divisible by 2. So just like odd integers, any two consecutive integers must differ by 2. So if we're talking about three consecutive even integers, let's represent them by x, x plus 2, and x plus 4 represent our consecutive even integers. Now let's analyze the conditions of the problem. The square of the sum of the first and second integers, so sum of the first and second would be x plus 2, and the square of the sum is equal to twice the third integer, so 2 times x plus 4. So this is the condition of the problem. Now let's proceed with the algebra. 2x plus 2 squared equals 2x plus 8. And remember, 2x plus 2 squared is something of the form a plus b squared. We can expand it as 4x squared plus 8x plus 4, and that's equal to 2x plus 8. Let's subtract 2x from both sides and subtract 8 from both sides to get the quadratic equation 4x squared plus 6x minus 4 equals 0. So let's write that again. 4x squared plus 6x minus 4 equals 0. We can start out by factoring a 2, and that leaves us with 2x squared plus 3x minus 2 equals 0. Obviously, 2 is not 0, so by the zero factor property, it must be that 2x squared plus 3x minus 2 equals 0. To solve this quadratic equations, we need two integers, p and q, so that the product is negative 4 and the sum is 3. Let's go through the list of factors and see if any of those pairs for p and q work. So we have 1 and negative 4 adds up to negative 3, doesn't work. Negative 1 and 4 does the trick. Multiplies to minus 4 adds up to 3. So we factor the left-hand side by doing 2x minus 1 over 2 x plus 4 over 2. That's equal to 0. So we have 2x minus 1/2 x plus 2 equals 0. Using the zero factor property, we get x is 1/2 or x equals -2. However, notice that x equals 1/2 is not an integer. The integers are the whole numbers. So 1/2 is not an integer, so we must reject this. This does not satisfy the condition of the problem, because if you look at the problem, find 3 consecutive integers. So it remains that x equals -2. That's the first even integer. X plus 2 would equal -2 plus 2, which is 0. That's the second even integer. And the third even integer is x plus 4, which is -2 plus 4, and that's equals to 2. So the solution to this problem, the 3 consecutive even integers that satisfy the conditions of this problem are -2, 0, and 2. Example 3. The hypotenuse of a right triangle is 1 centimeter longer than the longer leg. The shorter leg is 7 centimeters shorter than the longer leg. Find the length of the longer leg of the triangle. So let's look at a right triangle and label everything. So, the side facing the right angle, the 90-degree angle, is the hypotenuse. Let's call it H. The other two sides are the legs of a right triangle. As you can see, one is longer than the other, so that would be the longer leg. Let's call that L. And that would be the shorter leg. Let's call that S. By the Pythagorean theorem, we know that L squared plus S squared is equal to H squared. We're going to capitalize on this theorem to solve our problem. Now let's read through the problem again. The hypotenuse of the right triangle is 1 centimeter longer than the longer leg. So this means algebraically that H is equal to L plus 1. Second statement says that the shorter leg is 7 centimeters shorter than the longer leg. So this tells us that S is L minus 7. We have everything in terms of L, so let's use the Pythagorean theorem to solve for L. So we have L squared plus S squared, which we can replace with L minus 7 squared, and that's equal to H squared, which we can replace with L plus 1 squared. Let's expand everything. L squared plus L minus 7 squared. If we expand that, we'll get L squared minus 14L plus 7 squared, which is 49. And that's equal to L plus 1 squared, which expands as L squared plus 2L plus 1. Notice we have L squared, which is the same quantity on both sides of the equation, so we can cancel that out. And if we subtract 2L and subtract 1 from both sides of the equation, we wind up with the quadratic equation, L squared minus 16L plus 48 equals 0. It remains to solve this equation. So let's write that again. L squared minus 16L plus 48 equals 0. So let's go through the list of factors for 48. So we have P times Q equals 48, and P plus Q equals negative 16. So the factors of 48 are 1 and 48 doesn't work. Minus 1 and minus 48 doesn't work. 2 and 24 doesn't work. Minus 2 and minus 24 doesn't work. Do not add up to negative 16. 3 and 16 doesn't work. Minus 3 and minus 16 doesn't work. Next we have 4 and 12 doesn't work. But minus 4 and minus 12 does work. Minus 4 times minus 12 is 48. Minus 4 plus minus 12 is minus 16. So the left-hand side factors as L minus 4, L minus 12 equals 0. By the zero factor property, we have L minus 4 is 0, which means L is 4, or L is 12. Now let's see what happens when L is 4. Recall that S is L minus 7. So if L is 4, then S would be L minus 7, which is 4 minus 7, which is negative 3. And that's impossible, because S represents a side length and it cannot be negative. What about L equals 12? If L equals 12, S is L minus 7, which is 12 minus 7, that's 5. That's an acceptable answer. And H is L plus 1. That's 12 plus 1, which equals 13. Again, an acceptable answer. So there's one solution to this problem, namely that the longer leg of the right triangle is 12 centimeters. Example 4. A rock is dropped off of a cliff that is 256 feet above the river. The height h in feet of the rock after 10 seconds is given by h equals minus 16 t squared plus 256. How long does it take the rock to hit the water? We'll note that the rock will hit the water exactly when the height equals 0. Because here you have a cliff. Here's the water. Throw the rock. The rock hits the water precisely when the height above the water is 0. So we're solving the equation h equals 0. which means minus 16 t squared plus 256 equals 0. Minus 16 t squared equals minus 256. T squared is minus 256 divided by minus 16, which is 16. This means that t is negative 4 or t equals 4. But t represents time in this context, which means it cannot be negative, so we're going to reject that. We're going to reject t equals minus 4 because time cannot be negative. And t equals 4 seconds is an acceptable answer, so the rock will hit the water precisely after 4 seconds.